Okay, so what we're going to do now is look at how we're going to connect up the rest of that circuit. So, looking at where we are already, we have got to connect the input side of the first logic gate. So, we've got inputs A, B and C here. Now you can, if you really want to, label those up. So you could have this one is A, this one is B and this one is C, so your first three are labelled similar to the diagram. And when we look at the first connection, we've got key A, which is going to be input A, goes to pin number 1 of our first AND gate. So all we simply do is look at where A is, so that's going to be here, and then it's going to go here to pin number 1. So it's as simple as drawing a line which will replicate a wire up across there and going into A. So A now feeds pin number 1. I'm just going to rinse and repeat that process. So number 2 will connect to B. So from here we've got switch B, part B, going to pin 2 of that first AND gate. So this time, same again. We'll go from 2, try and make it as neat as you can, going into B. Now, what I would do is, because we have got pins 1 and 2 of the inputs taken care of, we can now look at where we're going to take pin 3, which is going to be the output of that logic gate. So pin 3, we can see here, is the output of this gate, and that output is going to go to pin 1 of the OR gate, gate 4, which goes to pin 1. So in order to complete that, we just simply go from pin 3 to pin 1 and straight across there, and that is it. So in terms of transferring a physical, or creating a physical layout from a simple circuit diagram, that is what we're going to do now, and just work through that. And that's what it means by drawing the connective wires, putting the wires in there and ensuring that they go to the right place. Now if you do put everything in the right place and then test it, it will work. If it doesn't work for whatever reason, might need to do some fault finding. Normally when people have built these, faults will occur in the location of your chip, so make sure you put your chip the right way round. So your ICs need to have pin 1s down there. Make sure that your little horseshoe indents are both facing the correct way. Make sure none of the legs of the pins of the chip have been bent over, because obviously it won't connect with the breadboard. Make sure that everything's lined up over here, so your signal is actually going in the correct column all the way down. Ensure you've got a good ground, ensure that is actually connected to 0 volts, and then you shouldn't have any issues. What I'm going to do now is stop talking and just go through and draw the rest of the connections on. So feel free to pause the video, have a go at doing this yourself, and then resuming it when you've built it, and you can check to make sure you've not missed anything. Okay, so I've just done a quick check there, and hopefully that is everything connected as it should be. Again, things to look out for, just if you are doing it the way I've done it, you might think, well, why has he done that? I've just tried to utilize the connections of the breadboard, so I haven't got too many wires overlapping, so that's why certain wires are above or below other ones. Some people miss out this sneaky little connection between 3 and 4 of the OR gate chip, but that's just there, which links the two together to accept 3 inputs. Other than that, it should work as intended. So when we flick the input switch, then any combinations of 2 switches switched on or at logic level high will illuminate the LED, so either A and B, or B and C, or A and C, or B and C, etc, etc. Hope you've enjoyed the video. Sorry there's a bit of an interruption in between the two, and let me know in the comments if it's been helpful and if you like any advice on designing any other circuits.